Okay. What we have is another example, one more final example on how to graph, all right, an absolute value function. All right, we're going to graph this and compare. All right, we're going to graph this puppy. First thing is, what we realize is we have identified the transformation to its parent function. Now, this is an absolute value function, so the parent function is absolute value of x. All right, and just a quick review, absolute value of x as the flying v. All right, looks like this right here. All right, with a vertex at 0, 0. That's the parent function. So we're shifting and transforming this parent function. Well, what's happening? Well, this parent function right there, if you look at inside, is going to move to the right 1 unit, right? Right 1 unit. Once again, we are looking at the shifts. When you have x minus h minus h means we're moving the right h units, so it's going to be the right one. We're then going to be moving it down 5 units, down 5 units. And then we have this right here, which is actually going to be a vertical shrink. Now, I explained what is the vertical shrink in my previous slides, or maybe previous lessons, so I want to check it out if you don't know why that is. But our a value, in this case, which is 1/2, it's the a value, all right, is less than 1, so that's going to be definitely a shrink, okay? We have that. Now, with all these transformations, we can now graph our absolute value function. We're going to sketch this graph. The first thing we're going to do, once we identify transformation, is we're going to find the vertex. Where did the vertex move to? Okay, where did the vertex move to? So the vertex starts at 0, 0, but then is now being shifted to the right 1. All right, so we're going to right 1, and then we're going to move down 5. 1, 2, 3, 4, 5. The stretch or shrink, because of the 0, 0, the original, multiplying by 1/2, the y value just changes to 0, so the stretch and shrink doesn't do anything to the vertex. It doesn't make it change or whatever. We just try to figure out, does it move to the right or left, or up or down? And so that's our new vertex. Our vertex is going to be at, what is it? 1 and -5. All right, so once we have this, we're now going to do a little table. All right, using our vertex that we have. We'll do the vertex, which is 1, -5. The vertex. And now we're going to plug in some values above and below it. 2, 3, and we'll figure out what those values are. So I'm going to plug in 0. I always go to the top, so I'm going to pay 1/2. And I'm going to multiply that by 0 minus 1. Plug that value in there. I know what the y value is. -1, 1/2 would be -4.5. -4.5. So right here, you can go over to 0, and we're going to have -4.5. It's going to be right there. And then we can go to -1. All right, -1, 1/2. We have -1 minus 1 minus 5. -1 minus 1 is -2. -2, actually value is 2. 2 times 1/2 is 1. And this is going to turn to 4. 4, so it will be right there. Connect the dots. And you can see that the absolute value graph is going to be a lot flatter than the previous one. Okay? All right, the parent function. Now from here, since there's symmetry over the y equals x axis, or over the vertex, we now know that our other values, we're going to need a 4.5 and -5, all right, for each one of these. So we can go over here, we're going to have the same value there, same value there, connect the dots, and there we have it, and that is our graph. All right, so we find our vertex first, check, and then we do our table, values, check, we plot everything, and connect the dots, or the points. All right, check, check, and we just did, all right, our transformation. All right, well, I hope this serves you well, and it will help you find and how to solve other problems. All right, good luck and God bless in the rest of your problems.